Okay, this is really cool. Meet your interstitium, a newly found organ. This was back in March 2018, and this is what interstitium looks like in a freshly cut piece. Now, here's what they have to say. With all that's known about human anatomy, you wouldn't expect doctors to discover a new body part in this day and age. But now researchers say they've done just that. They found a network of fluid-filled spaces in tissue that hadn't been seen before. Now, I'm going to explain to you, and we're going to see them in the mud fossils because I've been looking into these for 10 years. Now, these fluid-filled spaces were discovered in connective tissue all over the body, including below the skin surface, the lining, the digestive tract, the lungs, the urinary system, surrounding muscles, every single part of your body. They are membranes. I think they're still missing this a little bit. They are the membranes, and in these fluid-filled bags are bacteria that protect you. That is your immune system, basically. Now, it says previously researchers had thought these tissue layers were a dense wall of collagen, strong structural protein found in connective tissue. And they are, but they're not dense. They are really open. But the new finding reveals that rather than a wall, the tissue is more like an open, fluid-filled highway, precisely, said co-senior Neil Theis, a professor of pathology, New York Institute. Now, the one I work with, Gil Headley, I think I already mentioned his name. And again, he's not affiliated to me. I don't want him taking any heat for the kind of things I say. All I've ever asked him is, does this anatomically look like what I'm saying it does? And so far, 100% he said yes. Because I only send him stuff, and I'm going to show you the stuff right here in front of you. When you see it in a microscope, it can't be denied. It says the tissue contains interconnected fluid-filled spaces that are supported by a lattice of thick collagen bundles. I agree. Okay, get ready. We're going to be looking at interstitium. And we're going to be looking at it in this giant mud fossil, and we're going to be looking at it in my belt. Because interstitium is nothing more than a layer of loose connective tissue. And in belts, in leather, they tan it. And we'll see we're going to see these actual same structures here, the fibers, the whole thing, in my belt. Now, mucosa is the layer of skin, basically, or the organ layer of the membrane. This is the membrane, and it has one side is where they squirt out the mucus and so forth, and the other side butts up against your good flesh. And I'll show you as Gil does some autopsies. I think I'll probably put that in this video. Now, this is what they never saw before, because by the time they get it, it's flat as a pancake. I think I showed you some of the microscope slides, but they're just flat. And I don't use that microscope anymore. When we see what's coming out of this microscope, then you can see real, they never looked at mud fossils the way I'm looking at them. That's the only problem. Nobody's ever really expected this. So I'm not pointing any fingers at anybody, but I am pointing fingers at people that's job is to explore and study and understand and teach and profess and refuse to engage. That's the people with the CAT scans, DNA tests, specimens, everything I showed you. If you think I'm wrong, I would like to know why I'm wrong. That's what I want to know. I want to engage. Not allowed. And anyway, we're going to be looking at this here under the microscope, and it's up in there. And I have to wait and turn the lights down and put a little water on it, this and that. We're going to have a good time. Get the kids that love it. Okay, let's start with the bone ball and the fleshy, interstitium stuff right above it, which is this fleshy layer. And it's attached to the bone ball. Now, we're going to be looking at it in a microscope up here. Right up there. Now, I have to turn the lights off and home in on this a little bit. It's a little tricky because the lights have to be just right. Hold on one second. Alright, now, takes a time, takes a second to home in here. Now, this is what we're looking at. Now, I'm going to point out something. Right here is where the bone ball attaches to the muscle. And the muscle, you can see, is these fibers. And we're going to get real close to it. Let me see if I can home in a little better on this. Let me turn up the lights a little bit. Alright, now I'm going to turn it down a little bit. But I'm going to put my feather tip right where the bone meets the muscle. You see right here? That's it right there. That's where the bone meets the muscle. Right there. You see the two different textures. Now, the bone itself, what they would do is remove all this stuff and say, oh, that's just nothing, that's just a concretion. Look at all the layers of just sediment and so forth. Well, it's not that way. I can home in and out. See, I can come way out like this and go way down in and come way out here. That's what's cool about this microscope. So I can look at this part of the bone right up here right now and inspect that. That's bony material. Now I'm going to go a little deeper. Now we're down to where, and I believe this is an abrupt transition. These fibers are muscle fibers. Now let me see if I can adjust the light and see if we can see anything different. See, now we're getting down to the redness of the bone, how the bone looks a little different. We can see the abrupt transition of these fibers. These different colors are colors of blood. Alright, now when I come down close, we're going to see the collagen, really. Now I'm going to hit it with a little taste of water, because that usually makes a big difference in what you see. Especially when it's red and bloody. And it rehydrates like instantaneously. Now we can come up with the lights a little bit probably. Hold on, my friends. Where is my brush? Well, let's use this here. It's my toothbrush. I don't use it anymore for my teeth. Okay, now let me turn these lights off over here. We're getting light contamination. It's everywhere. You can't stop it. All right, here we go. Let's roast this up a little bit with some light. All right, now, you see the different colors? You see the different fibers? Now I'm going to come right down on top of it, and we'll look at what it looks like when I get really, really close. Let's just go with about, let's see, right about there. Now, it's going to take a second. Hold on. Alright, this is when you get really close to the fibers. You know what, let me take it right out of the holder. This is what's nice about this one. You can take it right out of the holder and go right on top. Dead on top. Boom. This is what the top looks like. It just looks like, you know, they would call this feldspar. But if you look and you know what to look for, all of these are fibers. This is all fibers in here. You see all these fibers? That's what let me turn the lights on and maybe we can see a little better. That's what tissues are made out of. They have all this different intricacy to it. See this? That's the best shot I think I'm going to probably be able to give you. Fibers, straps, gooey, wet, bloody, red tissue. And that's what we have in interstitium. And you can see, it's just what it is. Now, let me show you my belt. This is going to freak you out. What do you see this? Okay, this is pretty cool. Now, this is my belt. You see these little white fibers here? You see, and there's like little black balls here and there. You see this, all these fibers? Well, what's that all about? That's the belt. That's what's called interstitium. Now, this is what interstitium looks like here. You see it? They have all these black anchor balls, and then they have two types of loose connective tissue. They have one that's a real tough, loose connective tissue. That's a springy one that brings the fluid-filled bags back to their original positions. And then they have a real floppy one, which is this one. And these are the big, long strands. And the little brown ones are like these ones up in here. So they got the real big, long ones, and they got the little brown ones, and then they got the black balls every here and there. You can find them. Now, can I find that in my belt? Yeah, well, that's my belt. So yes, I can. Now, where can I see the fibers in their looseness? Well, let's see a belt buckle hole. Look at that. That's exactly what you find. All right, these are the little black balls here that are holding on to these straps. That's what keeps them anchored in your body so that you return to your present position after you go moving around, whatever you do. You see, and when you get off here into the Neverland, whoops, if I get way down here, and there's different densities of them in different areas. This is another area, you see? There's no stress in this spot. That's why you don't see any fiber specificity. You see? But they're all in there. But we're not pulling at them. When you get back up here, whole different issue. See the balls? Oops. Well, you can see them. They're all over. These are the little black balls. These are the fibers. And then there's another set of material in there that is the springy stuff. And these are all collagens. And this is exactly what you find on feldspar. There's no difference whatsoever. And I can show you that right now. Watch. Let me turn this little light on so that we can see down here. Now, what I'm going to do is I'm going to come down. That is the fingertip. Now, I'm going to take my little light out of here, my microscope, and I'm going to come over here and I'm going to show you those balls. wait, I'll show you. I'm right on it now. You can see that. Here's what they are. See them? They are everywhere. They're everywhere on this. You don't see the straps because there's no stress to it. It's just like the other thing. But you see all these little holes? This is the fingertip from the blood sample I sent off to be tested. I put a little water on this thing and blood will gush right out of here. Let me see if I can get deep in here and see. You see way down the side there? These are little blood vessels. That little red thing, I don't know what the hell's going on down there. Maybe she's growing. I had one that grew curlicues out of it. It blew my mind. I got pictures of it, I think right on here somewhere. But you see the little balls? They're everywhere. They're everywhere, everywhere, everywhere. And that's what keeps your skin anchored, and it goes back to where it's supposed to be when you're done. And that's this fingertip from this giant hand. I'm not making this stuff up. And that was DNA tested. So, you know, plus, watch this. Here's the goose. Here. The goose has the same stuff. Let me home in on it, and then I'll bring you up here and you can see. You see all the white fibers and the black and the little brown stuff? Let me turn the light down a smidge. Oops. Maybe I turn it up. No, let me turn it down. All right, you see it's basically the same stuff. And that's his feathers. Collagen is collagen. It's your barrier between the rest of the world and you. In your organs, on your skin, on your feathers, if you have feathers. So this is precisely what you would expect when this thing eroded enough and most of those bags emptied. You're going to end up with a ton of little black balls all over the surface. I just showed you that. Now, if you're interested in understanding this stuff, you need probably to get a good microscope. Now, I just think these things are cheap. I mean, I don't think this was even 20 bucks, less than that. And I've never had it out of the box, so I don't know if it's any good or not. I have a Celestron, which is probably a little more money than that, but you know, you can get, it's probably got the same guts to it. Who knows now anymore? But I like the one I've got. I've been using it for years. Works very well for me. I got the software. I can click it right into, and this does too. You can take this out with a laptop. You take it out with your laptop and go out on the field and you know, I had to break off pieces, bring it back to my shop. Okay, what I showed you was all a feldspar, and so is this feldspar right there, which is a bonehead. And here it is up in here. It's the same as all the rest of them. Let me turn off the big light. You see it? It's the same stuff. And that's on that bonehead. The aluminum silicates are in every type of feldspar there is. And let's look at the chemistry, but don't forget now. That was the bonehead right there that we were just looking at up here in the microscope. And it is all feldspar, and it is all collagen, and it all stabilizes with aluminum. When I show you this chemistry, you're going to freak again. Okay, this is going to be grisly, and it's going to be a dissection of a human body to show these layers of membrane. So if you're skittish or you won't have kids, you don't want them to see her, whatever you care about. But Gil Headley is the guy, and I'm going to be talking about him. And he is not associated to me whatsoever. Don't blame him for anything that I say. All I ever do is present pictures to him and say, is this anatomically correct? And he just says yes or no. That's it. And he says, I will never ever say that that is a certain body part from a certain creature. He will say it's anatomically correct, yes or no. That's all he has to do. He's an anatomist. He knows what they look like. He knows how everything works too. And he is fabulous. And a nice guy. Now, turn away if you want to turn away. Watch if you want to watch. Here we go. Now, this is Gil, and this is when the interstitial news broke. And again, I was working with Gil, 6-7 years prior to this on my Mudfossils. And again, I didn't really work with him much, but I asked him a question here and there. He's a PhD, and he owns, he goes all the way around the world, and he teaches everywhere, and he lectures, and, you know, he's the top shelf guy here. Now I'm just going to show you the interstitium. So here we have the flesh and so forth. Well, I'm going to just let him talk about it. Here goes.
Well, it's just on the belly and on the thigh. So here we're at the shin. Now you got this bone in the middle here, the tibia. You go on the outside, it's kind of meaty. There's a fibrous covering here, the deep fascia, the coral fascia. That's where we're having this image on top of the coral fascia on the side of your leg here. Now you can see again the superficial fascia has a shiny membrane over it, and inside the membrane system.
Now, here's what I want you to take away from this. Watch how everything has to slide and be mobile. And there is layer after layer after layer after layer. They just have no idea how many layers. Gil's basically the only one that did.
If I walked away from this with the halogen lamps, it would cook and turn into brown crispy bits. I can shove my hemostat under it.
Brown crystina is like a crust of it. Just as it is, what happens is as it hits the oxygen. This is all oxygen sensitive, so that's your body. I mean, any blood is oxygen. That's what happens. They transfer oxygen in and out. So when you talk about this brown crystina,
demonstrate some tensile strength.
Now all that stuff has to glide freely in your body.
Just pry it off. Just gonna tear it.
Look, you see the.
Now,
That's
the money shot. Did I get to the bottom of it? That shiny bit there, is that the deep fascia? If I took a picture now, would I be showing you the deep fascia? No. Turns out there's another layer of felt.
This is the key. They have no clue how many layers are in this. Gil literally is the guy that, as far as I'm concerned, he's tops in this fascia field. Anyway.
Sort of on the right, another transparent felty layer that would obscure the specific lines.
Look at how thin these layers are, and they still have.
So we got the layer that's over the fatty layer, the one that I already ripped away. We got
saturated with bacteria.
Right? How deep down the membrane rabbit hole are we going to go here until we finally hit the dense fibers of the deep fascia? Well, there does come a point as you pull these films away that eventually you find yourself pulling these silver strings. Then you know you've struck deep fascia. But on the way to it, how many membranes do I take away? 1, 2, 3, pretty common. It's dissectable as 3 membranes. I'm not telling you that there's 3 membranes there. I'm telling you I can dissect 3 membranes. Here we are at the back of the knee. This was the shot I showed you at the very beginning when I was telling you about so many times.
Anyway, this is enough for that. But trust me, in every single one of these membranes, these layers of very, very thin fascia, they have these bags, and the bags are saturated with bacteria. And if the bacteria is not there, you're invadable through that membrane. Just remember that. And that's why I keep talking about probiotics, because that's what lives in these membranes. They're called membrane-bound bacteria. If you can't bind them into your membrane, you're going to have to take probiotics every day, as far as I'm concerned.